So lesson 4.1, solving simple equations. So the goal today is to find the value of x that satisfies an equation, and I'm going to be instructing you on 3 different methods: inspection, balancing method, and using opposite operations. So in class we went through and we tried some of these examples already, and we started to talk about the different methods, and I'm going to clarify so that we have official notes for each method. The first method that most of you used is actually called solving by inspection. You look at the equation, you look at the values involved, and realize that you can predict the value of x that satisfies the equation without much math on paper. So it's math that you're doing in your head, because you already know your addition facts and you know that 4 plus 3 equals 7. Similarly, if you know your times tables, you'll realize that 5 times 8 equals 40, and you won't have to show any other steps aside from that. That's the inspection method. As the questions get a little more complicated, you may want to look into another method, which is called balancing, and that's helpful when guess and check or inspection isn't working. So balancing visually can be modeled using algebra tiles like we did before. So this here shows 2x, 2 colored in bars, plus 2 counters, 2 units, equals, or on the other side of the balance, 6 units. And what is happening algebraically when we're doing balancing is we want to remove all the numbers from one side and have them only appear on the other side, so that variables are by themselves and numbers are by themselves. So in order to do that for this question, we decide to subtract the 2, or get rid of these 2 counters. And remember, with algebra tiles, you do that by including the negative version. And because we're balancing, we need to do that to both sides. So this negative 2 that appears here in blue, and this negative 2, we've done it fairly so that everything is still balanced. But now, because of the 0 principle, these are going to be gone, and 2 of these will also be gone, because one will cancel with one, and the other one cancels with another. So what's left, or what my next line is, that all I have left is 2x equals 4. Now, we know that 2 times x, that's multiplication, equals 4. To understand with this visual image, I'll just move them down a little. Sorry, these 2 are gone. They were canceled out. They're still up here. Visually, what I'm trying to express is that each of these x's represents a certain set of values on the other side. What's represented here, or how we can represent it, is by trying to share evenly. So each of these 4 counters, we want to equally share them amongst the 2 variables, or the 2 bars. So that means that these 2 can go with 1 bar, and the other 2 can go with another bar, and then everything is balanced and equal. And algebraically, we show that using division, because division will undo the multiplication. So 2x divided by 2, we only have x, and 4 divided by 2, we have 2. So we get a solution of x equals 2 that satisfies that equation. And that's by balancing. Everything we've done to get rid of numbers on one side so that we only have variables left is done to both sides equally. On the left, subtract 2, subtract 2. On the left, divided by 2, and then as well on the right, divided by 2. Okay, and the last method is using opposite operations completely without having to show the balancing that some people like to show, but it's not necessary. And that would be similar to what students did in class today when they said, well, instead of adding, I subtracted, instead of multiplying, I divided. So right here we notice that there is a 7 on the left that we would prefer to have on the right. And if I look at it right now, it's a positive 7. So I need to name what's the opposite operation of positive 7. and that's negative 7. So if I want to move that to the other side using opposite operations, I will do that and change the sign. Everything else stays where it is. So the negative x is still there and the 10 is still there. But by doing this, I've accomplished what I wanted. Variables on one side, numbers on the other. If I simplify 10 minus 7 is 3, and I have negative x. You'll remember when we learned about variables and their coefficients that, in fact, there is a negative 1x here, or a coefficient of negative 1. I also want to undo that. I want to undo the negative 1 times x using opposite operations. So the opposite of multiplication is division. So underneath, if I were to divide by negative 1, and I'm showing it as a fraction, but you can also show it as a division symbol. So you could have negative x equals 3 divided by negative 1. Or sorry, balanced. Negative x divided by negative 1. Okay, you can show it with this symbol, but for the most part I'm going to be using the fraction bar because it's easier to see that these now cancel, and there's only an x left, and you have 3 divided by negative 1, which is negative 3, and that's the solution to this equation. So if I were to check 7 minus negative 3, that will equal 10. Okay, and there are 2 extra questions that I'm going to show you that we didn't do today in class, and I'm going to solve them all 3 ways. So inspection would just be guessing and checking to see what works. So you may just kind of look at this for a while and realize that because I'd like to double the number, that if I were to have x equals 7, that 7 plus 7 would be the same as 2 times 7. If I wanted to do it with balancing, so I start with 7 plus x equals 2x. I want all the variables together and I want all the numbers together, so I'm going to need to subtract an x from both sides in order to get rid of it. So I already have the 7 plus x. I will subtract the x, and then it won't be there anymore. But since I'm balancing, whatever I do to the left side, I have to do to the right. So what's left is 7 equals, well, 2x minus x is just x. So I get the same answer, and whether I read it forwards or backwards doesn't matter. 7 equals x is the same as x equals 7. If I were to show this using opposite operations only, I just won't be showing the fact that I've subtracted x from both sides. Instead, it'll look more like this. It'll look like this positive x is moving to the other side using opposite operations. So the 2x remains and the 7 remains, but the positive x moves and becomes a negative x. And 2x minus x is x, and it equals 7. So regardless, we get the same answer. Guess and check, balancing, opposite operations. And as I said, once the questions get a little more challenging, you may not be able to do it with guess and check or inspection right away. So I'm going to leave that for a second. You're welcome to try to guess the answer. Obviously, you can test it out and see if it works. Balancing, for this question, I'm trying to make sure that variables are together and numbers are together. So what I could do is, because I want to remove this 3x, I can remove it on the left. Just make sure to remove it on the right. So since we've done it on the left, as I said, we're going to do it on the right. Okay, and then we're going to simplify. So 3x minus 3x is now gone. So we have 4 equals 2 minus 3x, which is negative 1x. And we're going to do the division step as well to both sides. So 4 and negative 1x, but on both sides we need to divide by negative 1. By doing that, we have x alone and negative 4. So x equals negative 4 is the solution to this equation. If we set it up with opposite operations instead, like I said, it's moving the 3x to the other side using opposite operations. So 4 equals 2x. Instead of a positive 3, it becomes a negative 3. Then we simplify, like we did before, and we divide by the coefficient, or the negative 1, hoping to find the solution, which is x equals negative 4, same as before. So there's a few examples of the trickier ones for you.